start here with precalculus composite functions. What means by a composite function is that you're just going to combine two parts, two separate functions, and make them into just one function. Here we have the f of x equals 2x plus 1 and g of x equals 3x. And you're going to have it written out in a notation where it's read as follows: f composite with g at x is what they're asking you to find. And how you do this is you take your 2x plus 1 originally, and you're just going to plant in the 3x into where the x is. So if you can see here, again it's saying f composite with g at x means to take the f of x first, which is 2x plus 1, and implant into that the 3x, which is your g of x. So f composite with g at x just means take that 3x and put it into the location where the x is for the f, so that the 2x plus 1 is transformed where the x becomes the other part. The x in the f of x becomes the g of x. So 3x goes inside of 2x plus 1. You would just solve this normally now by multiplying the 2 times 3x and just adding the 1. So you'd get 6x plus 1. This is your answer when they're asking you to combine composite with f composite with g at x. This is how you would get the answer. So 6x plus 1 is the final answer for this part, but you can move on if there's another part that they ask you. The other part that they can ask you is f composite with g at 2. It means that you have to do all the steps as if you're finding it for x. But you have to go one step ahead now and take that 2 and put it in for the x. So up top originally we have the 3x, g of x equals 3x. We took the 3x, we put it inside of the 2x plus 1, so that the x in 2x plus 1 became 3x. And then, for this step, it's saying now, put the 2 in for the only point where you have the x, and then solve once you have done that. Once you've put the 2 in, you would just solve normally with normal multiplication and arithmetic here, and you would come up with at the bottom there 12 plus 1. If you went through with that, that would be 13. So the answer to that is 13. Another one to look at this is if it asked for f composite with g at 0, means you do the same thing. You put the 3x in for the x that is part of 2x plus 1, and then go one step ahead and put a 0 in for the x's. So that would be 3 times 0, giving you a 0, and 0 times 2 is 0 plus 1. And then that part would be the answer for f composite with g at 0. It's a little tricky on the way you read these because we're used to saying f of x or g of x. This is just a slightly more tricky way to say it. Another way to do it is you could also have a situation where they reverse it. Now we have g composite with f at x. Before we were saying f composite with g. So now we're flipping it. So you have to start with the g, which is 3x, and then for that x, put in the f, which is 2x plus 1. So it's opposite now. It's an opposite composite from the way that it was done originally. But then when you have it like this, they're going to go ahead to the next step. That's the answer for that part. But if they said for the x, we wanted you to go ahead and put in 4 for the x, which means G composite with F at 4, meaning put in a 4 for the x. It would be 6 times 4, which is what you put in for the x, plus 3. And then that would ultimately give you a 27. So there's the two ways to do this is F composite with G or G composite with F. And these are the two most common letters that are used with composite functions. But the hardest part is probably reading it right. F composite with G at X or some other